In this slidecast, we'll discuss multiple inheritance. Multiple inheritance is the ability of a class to extend more than one class. For example, a university has many students who are full-time students and employees who are full-time employees, but there are also some student employees. Here's a UML diagram that illustrates a student worker class that inherits from two base classes, student and employee. And this is an example of multiple inheritance.
If you were listening carefully there, you may have just heard my cat meowing in the background. Now, in multiple inheritance, the data fields for the derived classes are all inherited from its base classes. And multiple inheritance is a programming language feature that can lead to ambiguity. If a class extends two classes and they each declare the same data field, for example, we could have a name in both our student and employee class, it raises the question of which one does the derived class inherit. And in C++, the answer is both of them. And we'll show how C++ handles this. This is a primary ambiguity problem with multiple inheritance, and the Java programming language does not support multiple inheritance. Some of you have some Java experience. If you remember the interface support that's in Java, one of the reasons it's there is you can simulate or you can accomplish some of the things that you would normally do with multiple inheritance in Java. And you might want to go read on your own more about multiple inheritance and about Java's use of interfaces. Here's the definition of the student worker class. This is how you specify multiple inheritance in C++. So the student worker class extends employee and student. Now the constructor has two initialization expressions that are separated by a comma. So here's an employee initialization expression followed by student. And the first initializes the employee part. These are the data members inherited from the parent class employee. And here's the data members inherited from the parent class student. And notice both of them have a name. Now there's no argument given for the data fields hours or GPA, so they are initialized to default values. Now here's the implementation of the toString method in our student worker class. Now when we attempt to compile this, we'll get an error that says that the references to name and p_address are ambiguous. So here we're referencing address and then here name, and the compiler can't tell which inherited data member that refers to. So we can fix this by modifying the code in this fashion. Now we explicitly denote that we're referring to the name and p_address fields that are in the student class. So this resolved this error. It's not a very good solution because we still have two name data fields and two p_address data fields, even though the constructor sets them both to the same value. Because the address fields are the same, we could get a runtime error when the destructor for student worker is called. So a better solution is to recognize that these two parent classes have common data fields. These common data fields and their associated member functions, we could collect them into a separate class which could become a common base class called person. And doing this process it's known as refactoring, and it's often used in object-oriented design, but it leads to some similar problems because now there are two person components in the student worker, one inherited from employee and then the other from student. So maybe a workable solution to this problem is beyond the scope of this chapter. We won't discuss multiple inheritance any further in this course. There's more information about multiple inheritance in Appendix A if you'd like to study this issue further. And that brings us to the end of this slidecast.